We want to talk about the energy budget of the Earth, and in order for us to start, we have to start where? Sun. So if you look at the top of your paper, there is a big circle up at the very top and center. That's going to be the sun. So we need you to write in the sun. We're going to start at the sun. Why start at the sun? That is where all energy comes from. Your energy that you have right now, for your heart to beat, your lungs to work, your muscles to work, that energy originally comes from the sun. It all comes from the sun. The earth, all the weather, the temperature of our atmosphere, the winds, everything else comes from the sun. So we got to start with the sun, all of the energy that comes in. So we're going to go ahead and we're going to go from the sun to the right, and we're going to go over to the atmosphere. So we're going to fill in the atmosphere because we start out the sun. That sun going through space comes in through our atmosphere. And then, see this little mark right over here? We're going to go next. So we are going to go to the left again, and you'll see another little oval shape. We'll head on over that way. Maybe. Come on. Okay, there we go. All right. Energy budget. So, a lot of you are kind of getting a little confused about what a budget is, as I've been asking. What is a budget?
How much money it's like how much money a film costs. Like how much?
Okay, is it a limit?
Yes.
Yes and no.
You want to stay with it.
It involves two. Your budget should involve two things. What are they?
Your amount and
How much you are earning and how much you can spend, right? That's a budget. Okay, so it's how much you're gaining and how much you lose, and we want a budget between the two. Does budget have to deal with money? No, it can do all kinds of things. Yeah, it can be time. It can be like fuel. It can be anything. It really can be about anything. It's just a matter if something is coming in and something is leaving. That's going to be your budget. Well, when we look at energy, we're going to do the same thing. So when we look at energy, we have to look at the energy that comes in and the energy that does what? Goes out. What happens if well, let me ask you this. Ideally, what do we want for our energy budget? The amount coming in and the amount going out. Do you want to spend all of it? Do you want to retain some of it? Or do you want to keep all of it? Okay, money is a little bit different because you actually want to have that nice little cushion. Energy, we don't really want to save any. We want to use it all. But do we want to use more than what we get? No. So think about this. If we have 100% coming in, and we only use 50% of that, then that means 50% of it stays here. Which means what happens to our planet? If we have heat coming into our planet, and we only use 50% of that, and the other part is gone, then what happens? Okay. Then that means it should get warmer. Because 50% of it stays and retains here while 50% of it's gone, plus we have another 100% coming in, so we're increasing the amount of energy here. What if we get rid of more energy than we receive? Then it's going to get colder. So don't we really want to, whatever we get, we want the same to go out? We don't want to retain it. We don't want to lose any. We want to keep it in balance. If it keeps in balance, then life is good. Because really, the sun is that endless supply. It's like if you had an endless supply of money coming in, is it okay if you spend the same amount that's coming in? If you had an endless supply every day, same as coming in, then you wouldn't really have to worry about saving money. Wouldn't that be pretty awesome? You could always spend exactly more, or you wouldn't want to spend more than what you got, but you could spend exactly what you're coming in. And that's what we want to be with the sun. So when we look at energy budget, we want to make sure everything is balanced. What's coming in, same has to go out. So let's take a look at this. We're going to go down, and I think we're going to go off to the left side here. And we're going to look at the incoming shortwave radiation. Shortwave radiation. So we're talking about the smaller stuff. Shortwave has no impact on the atmosphere at all. None. It doesn't heat up the atmosphere. It doesn't do anything. It just passes through the atmosphere, comes right down to the Earth. The Earth absorbs all that energy, and then it's going to change it into a long wave radiation or infrared. Went to the left. So this short wave is good. It doesn't heat up the air, but the Earth does absorb it. You absorb that as well, and you get really, really warm from this. The Earth is going to change this into long wave. And let's see where we're going to go next. I believe we're just going to go straight down and to the right. Yep. So when we look at this energy, it's going to do two things. Either it's going to be reflected and scattered, or it's going to be absorbed. So we're going to stop and look at the reflected and scattered portion of it. And I apologize, this is kind of pixelated. It's really hard for me to use this stuff and go in close because it just zooms everything out. I need to use a different type of format for this. But for the most part, I think you're going to be okay. Well, I can't help that. Reflected, scattered, 30%. So out of that 100%, 30% of that is going to be reflected and scattered. Where is that going to go? So the first part we want to go is there is a down line off to the left, and it goes all the way down to the surface of the Earth. So a portion of that 30% goes all the way to the surface of the Earth, and it gets reflected. What can reflect that stuff? No, come on, we're talking about just, the surface of the Earth. Surface of the Earth, what's reflective? Water and anything else? Snow, ice, all that stuff. Okay, how much of it do you think actually gets reflected off the surface of the Earth? 50%? How much actually is being reflected and scattered? What does your paper say? 30%. So out of that 30%, how much of that is reflected by the surface of the Earth? 15%? Okay, we're going to go straight up. You said 3. It's pretty good. 4%. That's not a lot. 4% of that will be reflected. Not really a lot. Okay. What's 30 minus 4? 26. Okay, so we're going to go back up. 30 minus 4, so how much do we have left? 26. See this one right over here to the right? We're going to go on down that. So what else reflects and scatters? What does it say? What's the picture of? It's a cloud. Okay. So clouds in the atmosphere are also going to reflect that. So when it comes into our planet, how much is going to be reflected by that and scattered? Well, you already have 4% from the planet. We started out with 30. So 30 minus 4 is 26. So how much gets reflected by our atmosphere in the clouds? 26. Yep, 26%. Okay, it's really good. In fact, you saw this when we looked at the image. Remember when we saw Felix when he jumped out of that balloon? And you can see that blue ring. That is part of that 26% that gets reflected and scattered. Okay, that's the scattering of blue light. Clouds. Have you ever been above a cloud? No. In an airplane, if you've ever flown in an airplane, how many of you have flown in an airplane before? Okay, when you're flying above those clouds, are they bright? Yeah. Super bright, right? And it could be a great big storm cloud, and underneath it, it's all black. But you go up on the top, it's really, really white. Clouds are not black, they are white because they reflect it. The only reason why they're black is for the same reason if you take your hand and you look at the light above. So the top of your hand is going to be nice and bright, but what happens to the bottom part? It's dark. Why? Because it's a shadow, right? Why do you think clouds are dark? It's the shadow. Okay? So the thicker the cloud, less light can penetrate through it, and so what happens to the the shadow, does it get darker or lighter? It gets darker. So it makes sense that when we have these really dark clouds, they're really thick, full of energy, and so the cloud will look dark because it just doesn't allow a lot of light to pass through it. 26%. Okay, so we have the 30. 4% is reflected by the surface of the Earth. 26% of it is reflected by clouds and the atmosphere. And that shows us how much is reflected. So all that radiation that comes in from the sun, automatically, how much is reflected and scattered by the Earth? 30%. Okay, that means that it's gone. It hits and goes off and bounces out into space, and we never even see it. We don't even get to use it. Those 30% of that energy that actually comes here is totally unusable to us. It's gone. Bounces off the surface, and it's out in space again. So that leaves us with how much left? 70%. If I add 100 minus 30, then I get 70%. 70% is going to be absorbed, and the stuff that we absorb is the stuff we can actually use. So let's go back up here. There's your 30%. The 26 plus 4 is your 30%. Okay, we're going to go back over here where it says reflected. 70% gets absorbed. So 30% is reflected, scattered. 70% is absorbed. We're going to follow this line right underneath the percent sign. Where does that go to? A little circle. Okay. And then from that circle, where does it go to? No, a cloud. So what is going to absorb this? The cloud and the atmosphere. The circle is just going to tell us what percent. So we have 70. How much gets absorbed? So the atmosphere and the clouds are going to absorb 20% of that 70. Yep, that's the circle underneath it. 20% is going to be absorbed by clouds in the atmosphere. And if you go down to the next one, then you'll see the cloud, and yeah, clouds, atmosphere, absorb that stuff. Okay, so now if you look at this line here, where does it go to? Goes to the right, and it matches up with another line. So we're actually going to stop right here, and we're going to go right back up to the top where it said 70% is absorbed. Where does that one take us?
To the circle.
Down to the circle where? Close to what? To the surface. Okay. So we're going to go back up here, and now we're going to follow the one right off to here. Follow that down, and we're going to go down to the surface. So we had 30% reflected and scattered. 20% is absorbed by clouds in the atmosphere. So out of the 100, 50% is already gone. So we're ended up with 50% left. This 50% goes where? It goes down to the Earth's surface. Good. So it comes down here, and it's absorbed by the Earth's surface. So out of that 100, only half of it actually makes it to the Earth's surface and does its magic here. So we're going to go off to the right of this, and there should be another kind of oval shape. We're going to fill that in. Okay. So it's absorbed by the Earth's surface. So let's go over to that one over here, and we have that 50%. So from that 50%, we see 4 arrows that are moving outward. Yeah. So we know that that 50% gets divided 4 ways. Where does it all go? Okay, so we're going to start out over here on the right side. Spheric window is 5%. One thing that you do need to remember with all of this, absolutely, positively, one major thing. The radiation that comes down from the sun, gentlemen, this way. Okay? The radiation comes from the sun, long wave or short wave? It's short. And when the Earth actually receives that long wave, what does it do? Changes it into long wave. Long wave, you can feel it. That's infrared. Fireplace, you can feel it on your body here. It's nice and warm. That's infrared. So anything that's going to leave the surface of the Earth is going to be that infrared. It's going to be warmth. 5% of that stuff jumps out the window and is gone to space. 5%. That's a lot. I mean, it doesn't seem like a lot, but it is, because when you actually look at conduction and convection here, that's 7%. That's only 2% more than this. And this, do you remember what's so critical about this right here? Do you remember what's so critical about this right here? I'm going to bring this right over here. And I'm going to draw some of this stuff here. Just to see if we can make things a little bit better here. Okay. Take a look at this. We wrote down, there were 3 things down here. Okay, so we have the ground right down through here. Okay, and do you remember what I had down here? 5% and 7% and 23%. Okay, good. Which one is this? Do you remember? Yeah, and where does it go? Yeah, this is just going out to space. It's not going anywhere. So it's gone. So long, goodbye, adios. This one is 7%, and this one is really interesting. I like it because when you have the sun's way out here, right? And it sends down short wave radiation. Short. What does the Earth do with that? Okay, it actually soaks up that heat, and it's going to release infrared out. And you all know this. I think we talked about this the other day. When you're out there playing in the sprinklers all summer long, and then what do? You go jump out on the concrete because it's the warmest thing. You're like, yes, right? And you kind of gauge the day by how well you sizzle. You know, psst, yes, psst, or how long you stay on there. Okay, that's because the ground is releasing a ton of infrared. The interesting thing about this, the video we watched the other day with all the helicopters coming down. Okay, so I have an air particle here, and here, and here, and here, and here, and here, and here. Okay, when these little particles come zipping on down through here, and they touch that ground, what's going to happen to them? They're going to go from blue to red, because they're going to get hot. So all of a sudden, all of these outside particles, they're all like sitting like this. The hottest place on the ground, or in the atmosphere, the whole atmosphere, is only about that much above the ground. That is the warmest part of our atmosphere, is right away from the ground, because the whole entire atmosphere, everything that we know, and we're only going to go up into the top of the troposphere, okay, that whole area is heated by what? That's heated by the ground. It's heated by the ground. So obviously the warmest place is going to be where? Right next to the ground. And as you get farther away from that ground, what's going to happen? It's going to cool down. Okay, so this air here, it actually, literally, this is what happens. It starts to bubble up like this. Okay? And it will keep bubbling up, like when you blow a bubble in with, soap bubbles. Picture that, and it gets bigger and bigger, and then eventually what happens? It will eventually form this shape like this, and we call this a parcel. And eventually that parcel will break loose, and it keeps going up. As it goes up, that heat moves upward. When it gets up to the top of the troposphere, what do you think it's going to do? Can it go through the tropopause? No. So it actually moves over to the side, and then what does the air do? It starts to cool, and the air drops. And if we have a spot that's hot, then we end up doing this cycle over and over and over. What do we call this? Convection. Good. Convection. And what happens down here? Conduction. Guys, 7%. This whole process heats what? Yeah, it heats our air. This is why when winter comes around and it snows, guess what happens?
Air conditioning.
Big time, yeah. Okay. Okay, so if this was the snow here, then the snow covers the ground. Snow is really good at blocking what kind of radiation? Short wave. And so guess what happens? Yeah, that orange just bounces off, and so what happens to the ground? it cools down. When that ground is covered, it doesn't heat up. And so guess what happens to the air? It gets cool. It cools down. 7%. 7%. This is what is crazy, is that, to me anyway, forget that. That's just still even work. 7%. That's not much different than that. So as much heat that heats up our atmosphere goes out to space. Almost as much. Very, very, very tiny. Now, 23%. What does the 23% go towards? Yes, it only goes to one thing. It goes towards evaporation. So if I have water down here, and I have sunshine up here, and that sun is shining down onto this, that water is going to do what? Yeah, it's going to actually get a little bit warmer, and a little warmer, and then it's going to evaporate. Okay. Now, I'm going to assume that you kind of know what photosynthesis is. Photosynthesis is where plants can take the energy from the sun, put it into a chemical bond, makes sugar and carbs. We take that, we eat those carbs like cereal, breads, and other things that come from those plants. Then when we breathe in air or oxygen, we can actually release the energy from those carbs to give us energy to do our thing. Well, this is very similar to that. That energy comes in from the sun, and it goes down in here, and that energy is what allows water to evaporate. So when that water evaporates, that water has actually sucked up that energy, and it's trapped into that water. And when that water, so evaporation, does it take energy or does it give energy? It takes it, right? Because it has to warm up. So it has to take energy, and when it takes that energy, then it can turn into a gas, and then it will go up into the air. But it will do what? It will condense, and what does it condense into? Cloud. Condensation is the opposite of evaporate, and so what does condensation do with energy? Huh? Oh, thank you. What does condensation do then? It goes back into a liquid, and what do you think it has to do to the energy? If it takes energy to take water to go into a vapor, then what does it do with the energy to go from a vapor back to a liquid? It has to give energy back. So, guess what this does? It releases energy out into the environment. The top of the clouds give out a lot of energy, and that energy is known as latent, oh, that's horrible, latent heat. Latent heat, the word latent means hidden. You can't feel it, you can't, no wait, wrong. This heat over here, remember what that one was called? Yep, sensible heat, because you can actually feel it. So this is sensible heat. Man, that's become a big mess. Now this is latent heat. Latent heat, 25% of latent heat. Do you know what all of this causes? All of this right here. Weather. Put it over here. Weather. It's nice, isn't it? Okay, so weather. And when we have pressure moving up, we call that low pressure, and air that's moving down, we call it high pressure. What happens when you have air moving from a high pressure to low pressure? If you were in between it, you know what you call it? Wind. So even the wind, the rain, the snow, the sleet, the hail, all that stuff, the cloud formation, is produced by 23% of the energy that comes from the sun. That's what makes our world tick. Do we want this stuff? Yeah, our mountains wouldn't look anywhere near the way they are. We wouldn't have any fresh water here. Everything would just be blah. Okay, it wouldn't be very good. It would be kind of not a very nice place to live. So, going back. Go away. Okay? So we have evaporation, 23/7, evaporation. How much energy do we have at this point? Oh, yeah. Yep, so if we go 20, 23 plus 7 plus 5 equals 35, yeah. 35%. And then, if you remember, up here, we had how much? Do you remember?
20%.
Yep, 20% right here. Comes down and it's absorbed by the cloud, so we're talking about absorption. And then this cloud is going to send it out, so if we add 20 and bring that back in over here. Ooh-wee. Okay, now we have that 35. And bam, 55%. Right there. That's what makes up that 55% is the 20, the 23, the 7, and the 5. Add that up, 55%. How much do we have left now? Out of the 100. So we started out, well, 55. What do you have up here? Right at the top, you have 55 and 30, which is what? 85. 85 from 100 is? 15. No, it's 55. 15. She's like, huh? I don't get it. Let's go down to this one and look at this. Try to make some sense out of here. What doesn't make sense? Oh, I don't know. I'm good at math. I'm kidding you, okay? The last part of this that we need to look at is this part right here, that 15%. So we need 15%. Where does that go? Right here. Do we want the greenhouse effect? Yes, we do. Always. Yeah, we want greenhouse. We do want it. All right, let me ask you this, okay? I know this is silly, but it will hit close to home to some of you. Do you really want to go to bed at night, like in January, with no blankets on? No. Why? What happens? Yeah, you wake up like in the fetal position. All night long, you're like, right? Legs up, you're tucking in. You're grabbing pillows and putting on your body in places that's cold and hoping that you get warm. If you have stuffed animals, you're like covering yourself up. Whew. So rude. You're curled up in the corner somewhere. Okay. So my point is, do you want to go to bed with blankets on or not? Okay. The blankets are... Guys, the blankets that's the greenhouse effect. Without the blankets, what happens to you? You get cold. If we don't have greenhouse effect, what happens to us? We get cold. Do we want the greenhouse effect? Okay, perfect. We do want it, but you don't want too little blankets. I don't know about you, but in the wintertime, my wife takes all the blankets and I'm just left with that first little sheet that's really thin. All night long, you're like, and then you start stealing stuff, right? I don't have enough blanket. But then, if you steal too much and you have like 5,000 pounds of blankets on you, then you're like in a sauna sweating. Yeah, you're like, okay, gets way too hot. Well, welcome to the greenhouse effect. To Met, these gases here are those blankets. If we have too many gases, we have too many blankets. If we have too few gases, then we don't have enough blankets. So, we want them to be just right. We want greenhouse effect. We want greenhouse gases. We don't want too many of them. So, one thing that I look at with the greenhouse effect, these gases to me, this 15% is like a revolving door. You guys ever played with the revolving door before? Okay. So, the way that I look at this 15%, it goes up and it goes around the revolving door. If I have this revolving door up there, then there's a chance it may not actually go up. So if I have that X right there and that's round and you know that it goes around in circles, right? Okay, so when I have this gas that is moving upward, it gets caught in that revolving door and it will go around and around. But, ladies, gentlemen, there's a 50-50 chance that it might go out or it might come back down. And it will keep doing that. It always maintains this 15% as it goes up and down. And every once in a while, one goes out to space, but more energy comes back up and it goes around. Sometimes it gets shot down this way, sometimes it gets shot up that way. But if we put more and more and more up there, then it means that the door on this side, instead of being really wide, now is really narrow. And so it's harder for people to walk out of here, or those gases. So what happens? What happens to that 15%? It gets larger, it gets warmer. This is the perfect world. The 15, the 23, 7, and 5, all of that stuff is all the perfect world. That's what we want. Is that what's happening? No. It's not. Perfect. 55, 15 is what? 55 plus 15 is? 70. 55 plus 15 is 70. Plus 30 is 100. Are we at 100% then going out? Yes. Outgoing long wave is 100%. What did we want? We want 100%. Because the incoming is 100%. We don't want any extra. We don't want any less. We want the same amount going out. And so, in the perfect world, this is what should be happening. But currently, it's not. And so